Hello. Today we will be working with partitioning line segments. If you notice on the screen, you'll see that when we're talking about partitioning line segments, basically what we're saying that it's the coordinates of a point which partitions a directed line segment labeled AB at the ratio of A to B from, and notice what we're saying, we have capital A represents the first point, x1, y1, and we're talking about capital B multiplied to the second point, which is x2, y2. So this is the actual formula if we're talking about partitioning a line segment that is located on a coordinate plane. The first thing we're going to deal with is we're going to talk about how can we partition a line segment given a one dimension. And basically what we're saying is it's on a number line. So since we're talking about a number line, we're only going to deal with the x part. Let's go back. Notice we're only going to deal with the x part of our formula. Now, notice that each part has something that represents it. For example, this x1 is representing the first x coordinate, the coordinate of the first point. This a is representing the first part of my ratio, just like this a is. And of course, this b is representing the second part of my ratio, which is what this is. This x2 is representing the second coordinate, second x coordinate, and this x1 is once again reverting back to the first x coordinate of the first point. And it's the same thing for the y's. The y1 is representing this y1, this a is still representing that a, just like that one. This b is representing that b, this y2 is representing that y2, this y1 is representing that y1. So notice it's just a formula, but you have to make sure you know where all the parts go. All right, where the corresponding parts go. Since we're only talking about using a number line, remember when we're dealing with the number line is typically a number line is horizontal. So we're just talking about a number line. Of course, we can start at 0 and go 1, 2, 3, 4, 5, and so on. And then over here, we can go -1, -2, -3. Well, when we're talking about partitioning a line segment, we're basically saying that if I start out with a line segment here, and it ends here, and I give you a certain ratio of that line segment, then how can I figure out what would be the length from this part? Let's say this is X, Y, and Z. And I want to know what is the length from Y to X. Or I want to know what's the length from Y to Z. Well, that's what this formula right here would tell us. All right, that's what this formula. Notice this formula is just the x part of my full formula. So let's get started. So if we look at this, it says A is at 1. All right, A is at 1. And B is at 7. It says find the point T so that T partitions or cuts A to B in a 2-to-1 ratio. Okay? So let's label everything that we have. So if I label everything that I have, I know that when I'm looking at this, since we have this, we have our formula, which is, and let me write it down. I want to make sure I write it down correctly. We have x1 plus A over A plus B times x2 minus x1. Okay? So if that's the case, then what we're saying is this. We're saying that our x1 is represented by the point 1. Our x2 is represented by the point 7. Our A is represented by the point by the number 2 because that's what our first ratio is. And our b is represented by the number 1 because that's what the second part of our ratio is. And so now I just plug them in. So when I plug them in, let's look and see what we get. Well, that's what happens. Notice, I told you my x1, which we plug in, was 1. My a is 2, so I put it here. My a is 2, so I put it there and there. My b is 1, so I put it here. My x2 is 7, so it goes right there. My x1 is 1 again, and it goes right here. And notice when we go through and solve, we end up getting 5. Right? Now, it should be easy to plug it in when you have a calculator. Right? But if we did not have a calculator and we had to work it out by hand, well, of course, we know that this would say 1 plus 2 over 3 times 6, which will come out to be 1 plus 12 over 3, which will come out to be 1 plus 4, which equals 5. Okay? And notice that is our answer. Let's look at another example. A is at -6 and B is at 4. Find the point T so that T partitions A to B in a 2:3 ratio. And so what I'll do is I'll help you by let's labeling what we have. Well, we know that our x1 is equal to -6. We know that our x2 is equal to 4. We know that our A is equal to 2. And we know that our B is equal to 3. So pause the video for a moment and see if you can get the answer. The answer you should get should come out to be -2. If you notice, -6 represents x1, 2 represents A, 3 represents my B, my x2 is represented by 4, my x1 once again is represented by -6, and so therefore when I simplify that, I get -2. And we see that's where my answer is located. And so this represents my T. All right, that's my A, that's my B, this represents my T, because remember, the directions say we want to find the point T. But what happens if we're talking about partitioning a line segment and the line segment is on a coordinate plane? Remember, coordinate plane, basically some students think about it as being a graph, but it's really a coordinate plane. Coordinate plane has x values, has y values. That's the reason why we call it 2 dimensions. And so now, not only do we have to use the x part of our formula, but we also have to use the y part. And if you notice, the y part of our formula is basically set up the same way. The key is making sure that you understand what represents what variable. Notice right here it says A is at x1, y1, just like in the last example. B is at x2, y2. All right. Notice our x2 in this case, it also is a point. And remember, a point has 2 coordinates, an x coordinate and a y coordinate. So now let's look at some examples. So it says find the coordinates of point P along the directed line segment. So AB, segment AB, so that AP to PB is the given ratio. So they tell us what we have right here. Okay. So if we label everything that we have, notice we can label this as my x1 and y1. I can label this as my x2 and my y2. And I can label this as my A and this is my B. Well, thinking about what the formula says that if I wanted to find my x part, then I would actually plug it in. Notice my x1 goes here. This actually represents my A. We got 10 because in the formula it says that we're supposed to add a to b. So what I'll do is I'll actually write the formula right below it. So it's x1 plus a over a plus b times x2 minus x1, okay? Excuse me, x2 plus x1, I'm sorry. And then right here, all right, no, it is minus. I apologize. It is minus, all right? Because when we do when we go through it, I'll show you kind of how they got these things. And right here, it is y1 plus a over a plus b, parentheses, y2 minus y1. So if I plug in the things that we have, let's look at what we got. Well, of course, that's a negative 2. That's a 3 over 3 plus 7. This is 4 minus negative 2. And that's the reason why we came up with a positive 6. And then when we look at the y's, we've got 1 plus 3 over 3 plus 7 times my y2 is 5 minus 1. And if you notice, that's the reason why we came out with what we have right here. But we're not done, okay? Because now we set the problem up. Now we have to simplify these things, okay? Now we have to simplify them. And so when we're talking about simplifying them, notice that we end up getting negative 0.2 as my x coordinate and negative 2, excuse me, and 2.2 as my y coordinate. So this means that given these 2 points, this particular point that we found breaks AB up into a 3:7 ratio. All right, that's what it means. Let's look at another example. Find the coordinates of point P along the directed line segment AB so that AP to PB, excuse me, is the given ratio. Once again, let's label what we have. All right. And so if we label what we have, of course we know that this represents my x1 and y1. This represents my x2 and y2. This represents my A, and this represents my B. So therefore, I just plug in what I have. All right. And once you plug in what you have, you'll notice, and let's go back. All right. Once you plug in what you have, all right, you'll notice that once we simplify this, of course, we know 1/5 orders of operations. 1/5 times -5 gives us a -1. And so 8 plus -1 is 7. And right here, 1/5 times -2 is -2/5. And then plus 0 just leaves us with -2/5. And we can actually convert it to a decimal. -2/5 as a decimal comes out to be -0.4. Let's look at number 5. Once again, same thing. Given the coordinates, or find the coordinates of P along the directed line segment AB so that AP to PB, excuse me, is the given ratio. And one thing that you can think about right here is we can still label what we have. Remember, this is my x1, -4 is my y1, 6 is my x2, 1 is my y2, this 3 represents my A, and this 2 represents my B. So pause the video and see if you can come up with the correct answer. So when we set it up, notice when we solve it, we plug in our x1, which is -2, our A, which is 3. Remember, the denominator says that it's A plus B, so we're just saying 3 plus 2. That's how we get to 5. And remember, in the parentheses is x2 minus x1. So what we're saying is we're doing 6 minus -2, which gives us 8. Our y2 is, our y1 is -4. Once again, These two fractions should be the exact same, so that's the reason why we still have a 3/5. And then right here we're doing y2 minus y1, and so we're saying 1 minus -4, which gives us 5. And when you simplify those two, you end up getting 2.8 and a -1. So this is what we will use in order to partition line segments, whether we're doing a line segment via a number line or whether we're doing a line segment via a coordinate plane. Please use the notes that are on the website, the notes page labeled Partitioning Line Segments, to help you get organized with this. Thank you and have a great day.